Bouygues Travaux Publics, a subsidiary of Bouygues Construction, was awarded a contract in October of 2009 to build 2 road tunnels in Miami, Florida for $659 million. The tunnel will provide the Port of Miami with a second access road starting from the Downtown Expressway, I-395, passing on the MacArthur Causeway Bridge and connecting Watson Island to Dodge Island, where the seaport is located. This project consists of building 2 tunnels measuring 42 feet in diameter and 4,250 feet long with an earth-balanced tunnel boring machine. As the TBM moves forward, it erects a precast concrete liner that becomes the finished wall of the tunnel. This liner consists of concrete segments forming a ring, 5 standard segments, 2 counter keys, and 1 key complete 1 ring. In November 2010, Bouygues Civil Works Florida, a subsidiary of Bouygues Travaux Publics, commenced erecting a precast factory unit in the Sweetwater area of Miami. 1,520 concrete rings will be manufactured to become the tunnel liner. 6 steps are necessary to produce the concrete segments. A combination of number 4, 6, and 7 rebar are used to manufacture the rebar cage. Each rebar cage weighs 1 ton. Shear line machines produce the stirrups, and cutting bending machines are used for the curve and straight bars. "32 rebar cages are tire wire assembled every day on 5mm calibrated rotating jigs. The molds are cleaned with a scraper. All the concrete residues have to be removed. A concrete release agent is applied over the entire mold surface that will be in contact with the concrete. Plastic spacer wheels are clipped to the rebar cages before going inside the mold to allow for a concrete cover of 3 inches. The molds are closed following a predefined procedure. A calibrating jig is used to verify the correct closing of each mold. The segments are manufactured with an accuracy of within 1 millimeter. The concrete is delivered to a transfer area where the laboratory checks the consistency of the concrete. Cylinders are made to verify concrete strength at 7 and 28 days. 3 tons per square inch is the concrete strength that is required to offer a tunnel warranty of 150 years. The concrete mixers offload the concrete inside the Tuckerbilt. The Tuckerbilt is the machine that dispenses the concrete into the mold stations. The internal screw conveyor of the Tuckerbilt delivers a consistent flow of concrete inside the mold. The molds vibrate for 8 minutes while the Tuckerbilt dispenses the concrete, allowing the concrete to fill completely the form. 15 minutes after concrete pouring, the top doors of the molds are opened to float the extrados of the segment. Air bubbles and defects are eliminated using a specific design steel float. A curing compound is sprayed on the fresh concrete in contact with air. The bolts are unscrewed from the formwork side open. The overhead crane operator sets up the vacuum lifting device on the segment extrados, applies suction, and removes the segment. The segment is then moved to the evacuation line. A turning machine rotates the segment 180 degrees. The casting date and the plate identification are stamped on the segment. Guiding rods and rubber gasket are glued on each segment. A curing compound is applied on all the concrete surfaces not already treated. A 35-ton gantry crane is moving the segment to the storage area. The segments are stacked following a predefined order that will avoid excessive handling. The minimum duration for segment storage is 28 days before delivery. The segments are transported to the tunnel location via truck. 2 segments per truck because of the weight. Each segment weighs 13 tons. With a production of 32 segments per day, the precast activity will finish in February 2013 after 2 years of manufacturing. The entire precast yard crew has collaborated with pride and dedication to the technical and commercial success of the project.